Hello, welcome back. In this video, we'll get to understand what are Python operators, how to use them, the types of Python operators we have, and when and how they are being used. So let's get started. So in Python, we have some operators that allows us to carry out operations with the various data types we have in Python. So the types of operators we have are your arithmetic operators, your assignment operators, your comparison operators, your logical operators, your identity operators, your membership operators, and your bitwise operators. But we really focus on the key operators that we need to carry out operations as a data analyst. So the first operator we use is the arithmetic operator, which is based on mathematical operations such as addition, subtraction, multiplication, division, and a bunch of other operations in mathematics. So to use your mathematical operators, to use the addition operator, what you simply need to do is you get your two values. This is your first value. Say A is equals to 5 and B is equals to 3, right? Then do a simple addition using the addition symbol, which is the plus symbol. Then when we run this, we are going to get the sum of these two values, which is going to be 8. Then your subtraction would just be the same values, but now we are using the subtraction or the minus symbol, right? And we are going to get the actual value. Multiplication, when it comes to multiplication, we use the asterisk symbol, which is this symbol that looks like a star. Run it up and we get the multiplication between 5 and 3, which will give us 15. Division is your backslash. When you run it, you get your 5 divided by 3, which gives us 1.6 something. Let's keep going. So when I say floor division, it simply means give me the whole number, round down the nearest to the nearest whole number, right? Like when I divide this, when I do a division between two values, say 5 and 3, you divide it and give us the nearest whole number. Like this, in this scenario, we got 1.666, and the nearest whole number rounded down will be 1. It doesn't matter if this is 9, this is 9.99999, it doesn't matter. As long as the nearest whole number is this value, it's going to give us this value. It's not going to round it up. So this is what the floor division does for us. Then the modulus operator gives us the remainder of your division. Say I divide this 3 by 2. I divide 3 by 2, I'm going to get 1. Then the remainder would be 1. So let me make this, I think any values I divide by 2 should give me, let's use 4. The remainder will be 0, won't get a remainder. If I use 5, it's going to be 2, then the remainder will be 1. Always going to be 1. Is that 0 or 1? So the next operator you have is your exponential operator, which gives you the power. So if I want to get 8 to the power of 3, it's simply doing 8 divided 8, let's do this instead. 2. 2 is what's going to happen here is 2 times 2 times 2, which is 8, 2 to the power of 3, which gives us our exponential value. So let me do a quick example for us. Let's see these values in action. This one in action. Let's say if I want to get the check if a value is true or false, and I say if a value is odd or even number, let's say 3 divided by 2 equal to 0, means the value is print even. else print odd. So any value that is divided by 2 and gives you 0 means that value is an even number. When I run this, I'm going to get is an odd number, right? So basically your modulus will allow you to do something as simple as this, and you get the correct value for that. So the next operator we are going to talk about is the assignment operators. These are operators that allow us to assign values to our variable, which we've talked about in the past. And the first one is your equal to, just the single equal to. Single equal to allow you to assign a value to a variable, which we've done. Then there are some instances where you want to do an addition, but you don't want to have to write it out, right? So what you do is simply assign the value plus the new value you want to add to it. So this is basically what's happening in the back end. So if I have C, which is right now our C is 10, and I say plus equals to 5, what is going on behind is we are reassigning C to itself, so we are adding the new values to it. So this is basically what's going on in the back end. Let me just move this down here, run this up, and run this, and run this. Let's run this. We're going to get 15. Let me run this again and comment this one out, and then run this. We are going to also get 15, because this is basically what's happening in the backend. We're just adding this variable is equal to the variable, the previous value plus this new value, then do the addition, then add, then reassign that new value to the variable name again. So similarly, that's the same that's going on here. The same effect is going to happen here as well. Same effect is going to go on here, but this will just be for the floor, which is going to be, I think that should be 3, if I'm not mistaken. Yeah, give us the latest nearest whole number. For modulos, similarly, we're going to get the same thing. We are going to do the calculation here, then reassign it back to itself. Exponential, basically the same thing. So those are the key assignment variables operators that we have in Python. So the next operator we have is your comparison operator. This allows you to compare two values together and to get if they are true or they are false. When you do a comparison, you always get two values, right? You also get two possible values, which is if I compare two or more values together, I'm always going to get if one is better than the other, one is worse than the other, and it's always going to be either true or false, basically. So the operators that we have is the equal to operator. We can compare two values. If they are equal, they are the same value. In no ramification, they are the same data type, they are the same values, using the equal to symbol. So look at what we've got here. We've got A is equals to 5 and B is equals to 3. We ask, is A equals to, if you notice, we are using double equals to because when we are assigning, we are using 1 equals to, but when we are comparing, we are going to have to use double equals to make sure it is correct. Run this up. 5 is not equal to 3, so we are going to get false. Next one we have is not equal to, right? So if this value is not equal to this value, it's going to return true, which is true. We are going to get true. Next we have the greater than. We are comparing A is greater than B, and A is greater than B. 5 is greater than 3. We're going to get true for that as well. The next one we have is the less than, using your mathematical less than, and you're going to get false. Then the next one we have is greater than or equal to. So firstly, it's going to check if 5 is equals to, if you want to see this more clearly, so let's make this 5 as well. Make this 5 and try to run this. greater than b greater than this is going to get true. 5 greater than this. Okay, we're going to get true. Change this out. Let's see. 5 greater than b, which got true. So basically, it's almost the same thing. I think it works best with, let's try something else. Less than, let's use the less than. Okay, this should return true as well. It returns false. So it works best, as you can see. If, okay, I did not run this again. Let me run this again. Let's do this. Okay, let's use the greater than. So A and B are both 5. But when I run this, is A greater than B? I'm going to get false because 5 and 5, 5 is not greater than 5. 5 is equal to 5, right? So if I want to actually check if 5 is greater than 5 before, in addition to check if 5 is equal to 5, in addition to checking if 5 is greater than 5, I would have to include this, is 5 greater than 5, and also is 5 equals to 5. So when I do this, I'm going to get true either ways, okay? So let me bring this back to 3 and continue with the explanation. So A less than equals to B, this will return false because A5 is less than B. So 5 is greater than B, and also 5 is not equals to B. So I'm going to get false in this particular example. So you can see that we have 3 comparison operators: your equals to, your greater than, your lesser than, greater than or equals to, your lesser than or equals to, which are basically 5 comparison operators. Okay, so the next operator we have in Python is your logical operators. This allows you to combine multiple conditional statements together. So basically, we have this comparison operator. If I want to combine this and this to create a more complex comparison, I have to use my logical operators. And the logical operators we have are your AND, right, your OR, and your NOT. So what this AND simply means is, if this part of the expression is true, and this part of the expression is true, it will evaluate to true. But if this one is true and this one is false, it will evaluate to false. Simply put, that both of these conditions have to be true for this to evaluate to true. Okay, let me run this. So let's check. 5 is 5 greater than 2. 5 greater than 2. Obviously, 5 is greater than 2. The next one is 3 less than 5. Okay, I need to run this first. Let me run this. The next one is 3 less than 5, which is actually true. 3 is less than 5. When I run this, I'm going to get true because both of them are true. So I need to get true. So for all would evaluate to true if either this is true or this is true. It will evaluate to true. So let's check it out. Is 5 greater than 2? No, 5 is not greater than 2. But is 5, let's see, is 3 greater than 5? No, 3 is not greater than 5. I think this will evaluate to false. Let's run this up. Can you see? A, which is 5. Oh, sorry. 5 is greater than 2, right? But 3 is not greater than 2. So this is true and this is false. When I run this will be true, this will be false. But for all, either of them has to be true for it to evaluate to true. So since one of them is true, it's going to evaluate to true. So what does not do for us? Not simply negates the condition, right? So we have this condition here, which evaluates to 5 is 5 greater than 2. 5 is greater than 2, yes. Is 3 greater than 5? Okay, 3 less than 5, also true. So both of these are true. So we are supposed to get a true value as our output, but the not simply negates it, which is if we are supposed to have true, it's going to switch it up and change it to false. If it was false, it's going to switch it up and change it to true. So here we got false. So the next operator we have in Python is your membership operators. Your membership operators are used to test if a sequence has a particular value or object. And the keyword we use in our not operators is your in and your not in, right? So this is basically how it works. We have a sequence of value, which is a list, a tuple, a string, or list, tuple, strings, or dictionary, or set. Right? So what we do is say, is a particular item in that sequence data type. For example, we say 3 is 3 in this list, which is this value here. I think I don't have to make a list. Let's make a list 1. Let's put list 1 as well. Now run this, 3 is in here, so I'm going to get a true value, right? So the not true is basically the opposite of that. So if I say is, if I were to run this and I put not true, I will get a false. Is 3 not in list 1? Obviously 3 is in list 1. So if I try to negate that, I'm going to get a false because 3 is already in list 1. So normally if I say 3 not in list 1, it will return false. To return false because 3 is in list 1. So let me run this. You see false because 3 is in list 1. So let's go over this and return this. So the next one I'll say 6 not in list. Let me make this list 1. So it checks, is 6 not in this particular sequence? 6 is not here, so I'm going to get the true value. So the next operator we have is your identity operators. So what this operator does, it checks if two values are equal and they are stored in the same location in memory. What do I mean by that? In this example, x is this value, right? Y is this value. Both x and y have the same values inside of them, right? But when I try to equate, then z is equals to x, right? So when I try to run this, I say, okay, is x z? That means are they the same value? Are they the same thing in essence? Yes, they are. But when I say is x y, basically if you look at it, x and y are basically the same value. But the only difference is that I need an example of this. In programming, we have what is called each values are stored in a location in memory, right? So when I create this x, I created it as a new value and I assigned it to a location in my PC's memory. When I created y, I did the same thing and assigned this to a location in my PC's memory. But when I created my z, I did not assign any values to it. Right? I simply said my z is equals to my x. Simply means my z points to x, which x points to the value that is stored inside of here. And both this x and z are stored in the same place in memory. Since z does not have its own unique value, but the same values, they are stored in the same place in memory. So this z is just a reference to x. So essentially, x is stored in a location in memory and z points to x. So this value and this value would inevitably be the same value. Right? If I were to change z, say z is equals to, let's say, let me do something else. Let's say to the power of 2 and 2, and I say, let's add pink, let's put fish here, right? Then I print x, let me print my x, print x, I should printable. Let's see what is the error here. This assign this out of range. Okay, I can't assign out of range. Let's just change this one. I run this. You can see, if you noticed, this z, right, that I changed is affecting the values in x, right? When you see I have fish, I have apple, but I changed the value for banana to fish on z, but it's affecting x, which simply means that z is just referencing to x. It's not a new value on its own. It's simply referencing to x. So x and z are basically the same value, right? But x and y, let me show you y. Let me print out y. You see that y did not change. Y remains the same, even though I edited x. As you can see, y remains banana. So z and x are basically the same value, and I can change, if I change z, I change x. But when I do that for y, it doesn't change y because they are not stored in the same location in memory. So that's just what this identity values allows us to check for. So there's also the is not, simply means, is this value not the same thing as the other variable? If it's true, if they are not the same thing, it simply gives us true. My alarm goes ring. Just help me your phone when you come up.
6 o'clock.
Have you finished? And if I finish, at least I don't try today. If I really try, I shall, but at least I don't do something.
That's the truth, man. They'll do something. If they don't.
I do something every day at least. Go see more front. But the main thing I need to do, I never do one, which is to collect more money. That's the main thing that will get me closer to my goal. But this one, they get me close to my share, but I need to collect their money. Take their money. See the record. Now this alarm make me never. Okay. So the last thing we need to understand is when we are working with operator is the order of precedence, right? Order of precedence means the way in the priority that Python gives to each of these operators. So in Python, the order of precedence goes like this. If an item is inside of your parentheses, it is given the main order of precedence, then followed by your exponential, right? Followed by your plus. Okay, we're not going to talk about this binary, this bitwise, because we're not going to use this. Followed by your multiplication, your division, your floor division, and your modulus, right? Then followed by your plus and minus, followed by your comparison operators, your membership operators, then followed by your logical operators. So let me give you a quick example. If I have this value and I want to do an addition, what do you think is going to happen? It will first do this multiplication before it adds it up, right? But if I want this to be added up first, maybe I want to add 2 plus 3 before I multiply it by 4, I will have to look at my order of precedence and put my 2 and 3 inside of the bracket or the parentheses before I add the multiplication. So when I do this, I'm going to get different result, which is 14. But when I put my 2 and 3 inside of my bracket, it's going to take the bracket as a priority and run that first, which is 2 plus 2, which is going to be 5, times 4, which is going to be 20. So when you are doing any operation in Python, you have to consider the order of precedence. And basically, if you want to use it, it uses the board mass, which is your parentheses, or the pan mass, is the way they call it. But I call it the board mass. I call it the brackets, the exponential, which is your off, like your division, your multiplication, your addition, and your subtraction. And that's the order it goes. then you have this material, you can just go through it and play around with this to get more understanding on this topic. Like I said, what happens here, it uses this first, your comparison operator first, before it considers your and. So it's going to check for this, then check for this before it considers the and. This is not correct. This should more or less be exponentials. Exponents. Exponentials. So basically this would consider your this your multiplication first before it adds the subtractions to it. And run this and run this again. So you can, if you change this, it will do for, if you have a couple of equations, right, that are the same, maybe you have plus plus plus, it is going to go from left to right. That means it's going to check if this is greater than this, then what it gets from here is going to now check if this is greater than this. So that is 1 less than 2, yes. 2 less than 3, yes. So we're going to get a false. I'm going to return true for that result. So far we've learned how to use all the operators in Python, mostly the important ones. We learned how to do the arithmetic, the assignment, the logical, the comparison, the identity, and the membership operators. And we also understand the precedence of how operators are run in Python. So far you can work with each and every one of the operators. So I would advise you to practice what you've learned and get it used to you. And we'll see in the next video where we'll talk more about booleans. So see you in the next video.